Let x1, x2, x3 and so on xn be a random sample of size n taken from uniform theta minus half to theta plus half, where theta belongs to minus infinity to infinity. So if t1 and t2 are respectively the maximum and minimum order statistics, then which of the following statements are correct regarding the statistic t, which is nothing but t2 minus t1. So if we consider xi follows uniform theta minus half to theta plus half. So we can clearly see like so t1 and t2 here are minimum and maximum order statistics. So basically for a uniform distribution with an unknown location, so the pair t1 comma t2, the minimum and maximum order statistic, they are sufficient statistic for theta. But here like we were given t as t2 minus t1, which is range. So range is a function of sufficient statistic. It can be considered as a sufficient statistic only if it retains all the information about theta. However, this range does not like retain all the information about theta because it's not a one-on-one function of this pair t1 comma t2. So t alone is not sufficient, but in the key like it is given as option A is correct. So as per like some older textbooks, like it is often marked as sufficient for theta because it is a function of t1 and t2. Whereas if we consider the second option, second statement, t has complete set of distributions. So in the case of a continuous uniform distributions, neither the maximum nor the minimum, not their functions, they are all they are not complete statistics, because if we consider xi as uniform theta comma theta plus 1, so the statistic t is equals to t2 minus t1, the range does not depend on theta. So the distribution is also same for all theta. So there could exist so many non-zero functions of t whose expected value is 0 for all theta. So that is nothing but, that is like showing incompleteness. So therefore option B is, statement 2 is obviously incorrect, and statement 1 is also incorrect, but in the official ISS key they have given as option A as correct answer.